Hi everyone, welcome back to my channel. Today we're going to be discussing our fourth installment on probability, which is our conditional probability. Now, conditional probability links in with dependent and independent events, so I just want to quickly recap the difference between an independent event and a dependent event. So an independent event is where one event does not affect the other event, all right? So there's no effect. For example, if I were to flip a coin and I were to roll a dice. So if I were to flip a coin, the coin will land on either heads or tails. Now, whether the coin lands on heads or the coin lands on tails has nothing to do with whether the dice will land on a 1, a 2, a 3, a 4, or a 5, or a 6. So those two events are completely independent of each other because one doesn't affect the other. Then we have dependent events, and dependent events is where one event does affect another event. And that's, for example, when we're talking about no replacement or not replaced. So if we were to, for example, have a bag of pens and we take out a colored pen, and we were to put that pen down, and we're not putting it back in the bag, then that affects my next draw of a pen. So if I picked, for example, an orange pen and I take the orange pen out of the bag, then my second draw cannot be an orange pen. So my second draw depends on whatever my first draw was. And those dependent events are what we talk about when we talk about conditional probability. Now I'm just going to link in a few of the basics, and we're just going to go through basic probability as well as our basic tree diagrams, and then by the end of the video we'll be doing it without a tree diagram. Next question, we say that 2 flowers are picked from the garden. So now if I'm talking about 2 flowers being picked, that means that it's not being replaced. Because if I pick a flower, I'm not going to replace that flower. So I'm still going to see that I still have my 7 flowers in total. However, do you agree that once I pick one of the flowers from 7, I only have 6 flowers remaining? So if I were to pick a pink flower, I would only have 1 more pink flower, but I'd have 5 blue flowers, but that would still give me only 6 flowers left. If I were to pick a blue flower, I only have 6 flowers left to choose from, etc. So the first question says, what is the probability that both flowers are pink? So in order to answer this question, I'm going to draw a tree diagram. So if we were to draw our tree diagram, we know that we have 2 options over here because we have 2 different colored flowers. We have a pink flower and we have a blue flower. So we'd have our first pick and then we'd have our second pick. Now our second pick, we would be able to pick a pink flower or a blue flower, a pink flower, or a blue flower. Now, if I were to write out my fractions, I know that my first choice, I have 7 flowers because there's 7 flowers in total. Of those 7 flowers, 2 of them are pink and 5 of them are blue. So I have 2 out of 7 chance of picking a pink flower, 5 out of 7 chance of picking a blue flower. However, once I've picked my first flower, then the number of flowers I have to pick from decreases by 1 flower. Irrespective of what color my first flower was, my second flower, now I only have 6 flowers because there were 7 flowers. I've picked a flower, so now I have 6 flowers. So if I follow the tree diagram and I go and I say I picked a pink flower first. If I picked a pink flower, I had 2 pink flowers to choose from, but now I've already picked a pink flower, so that means I only have 1 pink flower left. However, if I picked a pink flower first, that means that I still have my original 5 blue flowers to pick from. If, however, I follow the tree diagram downwards and I say, okay, my first flower that I pick is blue, then I had 5 blue flowers, so now I would only have 4 blue flowers. But if my first flower was blue, then that means that I still have the same number of pink flowers, which is 2. So I'd still have 2 pink flowers. Now, if I were to do my outcomes and my probability, my first outcome would be pink, pink. My second outcome would be pink and blue, or I could have picked a blue flower and then a pink flower, or 2 blue flowers. So this is just listing my probability outcomes, the possible outcomes that I would have. Now, as you can see, if I'm saying pink, pink, PP, or pink, blue, PB, then I'm working from left to right. So I'm joining the two letters together, and that gives me one outcome. So if I'm working with a single outcome, I'm working from left to right and I'm multiplying together. So I would have 2 out of 7, which would be my first fraction, and I would multiply it with my second fraction, which is 1 out of 6. If I was going pink-blue, I would take my first fraction, 2 out of 7, and I would multiply it with the fraction of blue, which is 5 out of 6. So I'm following my tree diagram, branches left to right. If I go blue and then pink, blue would be 5 out of 7. And then I would multiply it by the pink branch, which is 2 out of 6. And if I were to do my last one, I would say 5 out of 7 chance of picking a blue flower multiplied by 4 out of 6 chance of picking a blue flower again. Now, if you look at these different options, so if we're looking at our diagram, can you see that my first probabilities, everything was out of 7, and my second probability, now I had out of 6 because one flower was picked. Then you can see what I've done to the number. So it was pink, pink, so I decreased it by 1. So it went from 2 pink flowers to 1 pink flower. If I look over here at the bottom of my blue and then blue, I had 5 blue flowers, but then my second blue flower I picked, I'd only have 4 to pick from. And that's how we would work with this. Now, for the question that says, what is the probability of pink, pink? There's only one option of both the flowers being pink, and that would be 2 out of 7 multiplied by 1 over 6. 2 times 1 is 2. 7 times 6 is 42. Simplified would be 1 out of 21. So that would be the probability of pink, pink. But the second question says, what is the probability of having one of each color? Now, if we think about having one of each color, now we have 2 different probabilities that fulfill this condition. So we could have the probability of it being pink first and then blue, but we could also have the probability of it being blue first and then pink, because they didn't tell us in which order the flowers need to be picked. They just said that what is the probability of having one of each color. Now, as you can see over here, if there are multiple probabilities that fulfill this condition, then I'm able to add them together, because now I'm working top to bottom, which means I'm going to add the 2 together. So if I'm doing this probability here, I'm going to say the probability of the pink and blue, probability of pink and then blue, and I'm going to add it with the probability of blue followed by pink. Now, if I'm doing that, then that means that the probability of pink and blue, I'm going to take them from here and I'm going to fill them in at the bottom here. So it will be 2 over 7 multiplied with 5 over 6, because that's the probability of pink and then blue. Then I'm going to add it together. So I'm still going to add here the probability of blue and then pink, which is 5 over 7 multiplied with 2 over 6. So 2 times 5 is 10 over 7 times 6, which is 42, plus 10 over 42, which gives me 10 plus 10, which is 20 over 42. And 20 over 42 is going to simplify down as 10 over 21. And that would be the probability of picking one of each of the flowers, or each of the colors. There's a bag of colored discs, and the discs are green and pink. There are 6 green discs and 4 pink discs. So how many discs do we have in total? So in total we have 10 discs, because 6 are green and 4 are pink. 3 discs are removed from the bag at random and are not replaced. So we're working with our conditional probability. So we have 3, and they are not being replaced. So that means that if they're not being replaced, we start with, on our first draw, we have 10 discs to choose from. On our second draw, we only have 9 discs to choose from. On our third draw, we only have 8 discs to choose from. So question number A says, what is the probability that all the discs will be green? So we would be able to draw a tree diagram. And if you want to draw a tree diagram, just jot down your little tree diagram. You'll be able to do your 2 options, green and pink. However, we don't necessarily need to draw out the whole tree diagram in order to do our conditional probability. So 3 discs are removed from the bag. What is the probability that all 3 discs are green? So that means, what is the probability of green, followed by green, followed by green? So that means that it will be the probability of the disc being green multiplied with the probability of the disc being green a second time, multiplied with the probability of the disc being green a third time. Alright, so how many green discs do we have? For the first draw, we have 6 green discs. So there's 6 green discs out of 10 discs in total. Now, for the second draw, my 10 discs go down to 9 discs. And for the third draw, my 9 discs are now 8 discs. So if I drew a green disc the first time, then the second draw, now I have 1 less disc to draw from, green. So now I only have 5 green discs. Now if I drew another green disc, then that means there's no longer that green disc in the bag either. And now I only have 4 green discs to choose from. So that's how I'd be able to work it out. Now, because there's only one combination of green, 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 that means I'd only be working theoretically through my tree diagram from left to right. There aren't more than one combination that satisfies that requirement. So that means that 6 times 5 times 4 is 120. Over 10 times 9 times 8 is 720. And when I simplify that down, I get an answer of 1 out of 6. So I have a 1 out of 6 chance of all 3 of the discs being green. The next question says, what is the probability of removing a pink disc, then a green disc, and then a pink disc again? Okay, so now I'm saying, what is the probability of picking a pink disc, followed by a green disc, followed by a pink disc again? So now this is a specific order. So they want the pink one, then the green one, then the pink one again. So that would be the probability of pink multiplied with the probability of it being green, multiplied with the probability of the last disc or the third disc being pink again. So that will equal. In my first, so I have 3 sets of multiplication, 3 sets of fractions that I'm multiplying. So for my first draw, I have 10 discs to choose from. If I'm not replacing a disc after my first draw, I then only have 9 discs to choose from, and then I only have 8 discs to choose from for my third draw. Okay, so the probability of it being pink, then green, then pink. What's the probability of it being pink? Well, I had 4 pink discs to choose from originally out of 10. So now once I've drawn the first pink disc, I now only have 9 discs left, but I didn't draw a green disc, which means that I still have my original 6 green discs. But then for my third disc to be pink, now I only have 8 discs to pick from because it's my third pick, but I already picked a pink disc first, so now I no longer have 4 pink discs, now I only have 3 pink discs left. So now I'm just going to multiply these together. 4 times 6 times 3 is 72. Over 10 times 9 times 8 is 720. And when I simplify this down, I have a probability of 1 out of 10 of having that specific order. A fish tank has 20 fish in it. All right, so now I have 20 fish in my fish tank. There are 4 jellyfish, 10 yellowfish, 4 starfish, and 2 whales in this tank. 2 fish are removed from the tank to be placed in another tank. So if they are being removed from the one tank and being placed in another tank, then that means that they are not being replaced in the same tank that they were removed from. what is the probability that the fish will be the same? So 2 fish are being taken out each time, and what is the probability that the 2 fish would be the same? Now, it's not saying which same they need to be. So it's not saying that they both need to be whales, they both need to be starfish, etc. They're saying that they just need to be the same, which means that this, to work with the same fish, there are a few different ways or a few different probabilities that will fit this condition. All right? Conditional probability. Because both fish could be jellyfish, or both fish could be starfish, or both fish could be whales, etc. So now we have multiple different ways that could satisfy this. So that means that it could be that both are jellyfish, or both could be yellowfish, or both could be starfish, or both could be whales. So these are the different probabilities that would satisfy this condition of saying that the fish have to be the same. All right, so if we're looking at the fish being jellyfish, if they both have to be jellyfish, how many jellyfish do I have in my first draw? I have 4 jellyfish out of 20 fish in total. I'm going to multiply that with the probability of the second fish being a jellyfish as well. So look here. I'm going to get rid of this jellyfish. So now the jellyfish was removed. So now we can clearly see that we are left with 3 jellyfish in the tank. Okay, and now we don't have 20 fish in the tank anymore. Now we only have 19 fish. So 4 over 20 times 3 over 19 gives me my 12 over 380. All right, so that's if both fish were jellyfish. What if both fish are yellowfish? All right, so what's the probability of drawing a yellowfish first? We have 10 yellowfish out of 20 fish in total. All right, so now if I were to draw this yellowfish, so I'm getting rid of the yellowfish that I've drawn. So now I've taken it out of the fish tank. How many yellowfish am I left with? I'm left with 9 yellowfish out of, now I've gone from 20 fish down to 19 fish. So 10 times 9 is 90 over 380. What if both the fish were starfish? So first choice that I have is 4 starfish out of 20 fish in total, multiplied with, if I get rid of a starfish, so there's my starfish, he's gone. So now how many starfish do I have left? Now I only have 3 starfish left out of, and instead of 20 fish in the tank, I only have 19 fish left. So I have a 12 out of 380 chance or probability of picking 2 starfish in a row. If they were both wet, so I have 2 whales to start off with out of 20 fish in the tank. Now, if I were to get rid of this whale, I'd be left with 1 whale out of 19 fish left over, and that gives me a probability of 2 over 380. Now, those are 4 different probabilities. So each of those probabilities we worked with, and that would be the probability of picking the same fish. But there are 1, 2, 3, 4 different probabilities that satisfy this. So my total probability would be equal to, because they're all out of 380, it would be 12 plus 90 plus 12 plus 2 out of 380 chance. So that gives me 116 out of 380 chance of picking 2 of the same fish, and that simplified down becomes 29 over 95. So I have a 29 out of 95 chance of picking 2 of the same fish. All right, and then the last question, what is the probability of removing a jellyfish and then a whale? All right, so now I'm working with a specific order. So I want the probability of a jellyfish and then a whale specifically. Okay, So I'm picking the 2 fish. First it's going to be a jellyfish, then it's going to be a whale. Now, how many jellyfish do I have? I had 4 jellyfish out of how many fish were in the tank? 20. And then a whale means that I'll need to pick a whale next. How many whales do I have to choose from? Because the first one wasn't a whale, the first fish was a jellyfish, that means that I still have the original 2 whales to pick from. However, I no longer have the 20 fish in my tank because I've already picked a jellyfish. So now I only have 19 fish in my tank. 4 times 2 is 8 over 20 times 19, which is 380. And that all simplifies down to 2 out of 95. I hope that you've enjoyed this video. I hope that it's helped you. Our next video on probability will be Venn diagrams. Hope to see you again soon.